So today's topic is, let me just, this one. So today's topic is join subqueries and views. So we are in third week. So let's get started with the presentation. So the topic we are going to cover include joins, and we'll talk about table relationship with primary key and foreign keys. And we'll see the concept of union, subquery, and view. So let's start with a join. So join basically combines records from two or more tables to produce a result set. So join is a means for combining fields from two tables, for example, by using values common to each. So the way that you can specify a common values is using where clause, and we're going to see that in a few seconds. And these joined tables are typically related with foreign keys. There are four different types of joins: cross join, inner join, and outer join, and self join. In most cases, you are dealing with either inner join and outer join, and more likely with inner join. So let's talk about the cross join. Cross join matches each row from one table to every row from the another table. So it actually basically creates Cartesian product, and of course is very costly in terms of CPU time. And basically, if you happen to have 1,000 records in table A and another 1,000 records in table B, the Cartesian product will result in 1,000 times by 1,000 times, which result in 1 million records in a result set. So it's rarely used in production environment. By the way, cross join is a default. So if you don't specify how to join rows from different table, the database server will assume you want cross join. So these are examples. So there are two different ways that you can have a cross join. So typically when you say select, and this is the name of the column, and here I just want to actually get ename field from employee table and salary from employee table and dname from a department table. And here you say from employees and departments, two tables with a comma. And here we use the alias. So this one, because you haven't specified anything, it assumes that you want cross join. Now, if you want to explicitly specify you want cross join, you can say cross join like this. So from employees and cross join and departments as a second table. Okay, so suppose we have these two test tables. One is departments and the department number 1, 2, 3, 4, and these are department number names with the column name dname. And these are employees table, and we have employee name and department ID. This is the foreign key field pointing to department. Pointing to department table, and these are 1, 2, 1, 2, 3. These are the values from department ID, the primary key field from departments table, and then salary field. So let's say we have these two test tables. So if you actually want cross join result set, basically it will result in 24 rows. So 6 times. So basically 4 times 6. So it will result in 24 rows. Okay, so that is cross join. Now let's move on to inner join. So inner join, as I said, is the most popular type of join. And among the inner join, the most common type of inner join is what is called the equijoin, where certain fields of the join tables are equated to each other using equality operator. Now, inner join requires a match in each table. So that match condition is again specified in where clause, which we are going to see in a second. By the way, rows that do not match are excluded from the result set. And as you will see later on, this is the difference from outer join. Okay. All right, so let's see examples. So by the way, there are 4 different ways that you can specify inner join. So here we say select and the fields from these two tables, and then we say from the names of the first table and the second table, and then we basically specify the equality condition using where clause. So here, department number specified in the employees table is the same as department number of department ID of departments table. So basically what you want to do is I want to display all the employee and this information, these three fields from these two tables, where the employee who has a department ID. So you do not want to display employees who do not have department ID assigned yet. Okay. All right, so we'll see that example in the following slide. So this is another way that you can use inner join. So here you say from employees, and then you specify join and the same where clause. Here you can also specify inner join as well. Okay, so this is the same thing as this, and instead of using where, you can also specify on. Okay. So this is probably the most common form of inner join example you probably see, the most simplest way. All right, so if you display inner join result set, you are going to see this 5 because we are going to see the e-name, salary, and d-name. And basically what you want to display is all the employees who has department ID assigned. Okay. So from the 6 people, if you remember the test table, we have a test table that contains new person who do not has the department ID assigned. So that's the reason we don't see this new person in the result set. Okay. All right. So we see these 5 records in the result set. So that's inner join. Outer join, the all records from one side of the join are included in the result set, regardless of the fact that whether they have a matched records in other side of the join, meaning in the second table. So as I said, this is the difference from inner join. Now, depending on which table you want to include, which side actually the join is included, you can have left join or right join. So outer join basically can be either left join or right join, depending on which side of the join will be included. So left join, all records of the table on the left side of the join will be included. That's left join. Right join is the other side. All records of the table on the right side of the join will be included. Okay, so let's see example of this. So the way that you can specify the outer left join is basically you say left join. Okay, so when you say left join, that means outer left join. Okay, so here the employee is the left side, right? So all the employees, regardless whether that employee has a matching the department ID in department table or not. Okay, so the result is going to be like this. So we have the employee who do not have the matching employee ID, department ID is included in the result set because we actually chose a left join. Okay, so all records of the employee tables are included in the result set regardless of the match because employee table is the left side of the outer left join. Okay. On the other hand, if you want to do right join, outer right join, basically you say right out join. So all the records in the right side of the join, outer join, will be included, and that's the department. Okay. So in this case, we are going to see, you see actually department ID here. Okay. So this is the employee name, salary, and department name. There is actually no one that is assigned to department HR, but still is included. Okay, because we chose right join, outer right join. So every record in the right side of the join, which is actually in this case departments, will be included in the result set. Okay, so let's do our first demo. So let's go to our lab documentation. So this is exercise 1. So we are going to set things up. So, you want to move on to your MySQL underscore join hands-on lab, the root directory. Okay, so which I've done already. And then we're going to start the MySQL shell. MySQL -u root -p and no password. And you have to specify what database you want to use as a default database. So we are going to still use MyDB. Okay, so database has changed. Okay, and so this is the join table, the exercise. So first of all, we are going to create a department table, and then we're going to create the employees table. So those are the same tables that you have seen in the slide. And then we inserted those 4 departments. And then we have inserted 6 employees record. Okay, so you can see new person doesn't have department ID assigned. Okay, so let's run the file using source command. Okay, so if you want to see departments, select start from department. So we got 4 departments, and employees, we are going to see 6 of them. Okay, so again, you see new person doesn't have a department ID assigned. All right, so we are going to try cross join. So you can certainly find out the join command information by just typing help join. Okay. All right, so we are going to try cross join. So here we are going to try both formats. So here, this is a default. Okay. And here we are going to specify the cross join explicitly. So that's cross join SQL file. So we are going to see the result of it. So as expected, we see 24 records in the result set in both cases. Okay, all right. Inner join. So as we learned, there are 4 different ways that you can specify inner join. Okay, and if we run the inner join as expected, we'll see 5. Oops. Okay, so we have 4 different inner join syntax. So you can see all 5. So there is no record that do not have a matching the records between these 2 tables. Okay, so 5 employees. Okay, so that's inner join. And outer join, we are going to try left join and outer join. So in these 2 cases, the tables on the left side is employees, and then we are trying right join. In this case, the department employees. You will see actually the same result between this and this. Okay, because this is the left join and this is right join, but we just changed the department. So this time we have a department on the left side and employees on the right side. So this one should have the same result as this one. Okay, same thing with this one. So this one should have the same result as this one. Okay, the left join and right join is the switched, and the tables are switched. So that should actually work in the same way. And so this is the route, the outer join. Okay. Yeah, right. Yeah, we basically use the outer, the explicitly. Okay. All right. So let's try that. Okay. So as you can see, depending on which table is included, you can see there are this is one. There are, in fact, this is the employees is on the left side and it's a left join. So all the employee records are there, regardless whether it has a matching the department or not. Okay. So this is a case that in this case is the right join. So all the departments are included. meaning all the department records are included, regardless whether it has any matching employee or not. Okay, and as you can see, this one should have the same result as a third. Okay, because as I said before, the left and right tables are exchanged, while the left and right joins are also exchanged. All right, so moving forward. Self-join is something I have not explained. It's basically you are using a same table for joining. So in this case, I'm actually self-joining, and getting the e-name and salary information from employees as E1 and employees as E2. Okay. So in this case, we're going to actually see 36 rows. Okay, because it's 6 records by 6 records. Okay. So let's try that. Yeah, self-join is rarely used, but it's okay. 36 rows in a set. All right, so let's move on to the next topic. So table relationships are basically constructed through the use of primary key and foreign key. So as we learned last week, week before, primary key is a field or a combination of fields that uniquely identify a record in a table. And foreign key, sometimes referenced as a referencing key, is a key that is used to link the two tables together. And you are going to typically take the primary key field of one table and insert it into another table, and that table, that column where the primary key of the first table is included becomes a foreign key column. All right, so this is an example. So we have departments table here, and department has a department ID as a primary key as specified here. Okay, and then we have employees table, employees table, which has its own primary key, and then it has a foreign key column, D_ID, and the foreign key is specified with this. So foreign key, the name of the column, okay, and that's DID in this case, and it references department, the table name, and table's primary key field. Okay, so this is the way you can specify which column of your table is in fact the foreign key, and which primary key field of which table is specified with this departments table and department ID. Okay. All right. Table relationship. Types of relationship. There could be one-to-one relationship, or it could be one-to-many, or it could be many-to-many. So one-to-one many relationship means a person, in this, for example, a person has one primary address. Okay, so that is one-to-one matching between person record and the primary address record. And so person table has a one-to-one relationship with the primary address table, and the primary address field has a foreign key field referring to the primary key field of the person table. So this is an example. So we have a person table and the person ID, which is a primary key field. And then we have primary address table, which specify a column, PID here. This PID foreign key column references the person ID, primary key field of person table. Okay. Okay, so if you construct, if you actually put some the data into these two tables, and you probably see you are going to see PID column, which contains primary key values of this person table. Okay, so this address belongs to this person, this address belongs to this person, this address belongs to this person, and so on. Okay, one-to-many relationship, on the other hand, has that one table has so probably it's easier to explain in an example. A department has many employees, and employee belongs to only a single department. So in this case, department and employee has one-to-many or one-to-n relationship. Okay. So in this case, employee table has a foreign key field referring to the primary key field of the departments table. Okay, so let's see an example. So again, this is the departments table, and then this is the employees table, and employees table has a DID which references departments tables department ID. Okay, so this is an example. So this is a foreign key field of the employees table, which references to department ID primary key field of the departments table. Many-to-many relationship. Example is a student can take many courses, and each course could have many students. So in this case, student and course has many-to-many relationship with each other. Now, to represent many-to-many relationship, you need what is called the join table, or is sometimes called the intersection table. Okay, so in this case, student and course table, so this is the intersection table or join table, has a foreign key fields to both student and course tables. And the primary key also is a combination of student and courses primary keys. So it doesn't have to have its own primary key field. Okay, and that's typically the case. Okay, you don't have its own the primary key column. Instead, the composite of the student and the course's primary keys, should be good enough. That should be unique enough to be used as a primary key. Okay. Now, this intersection table could contain other fields of its own, such as, for example, course registration date, meaning when that particular student has registered for a particular course. So in this case, we have a student table and course table. So neither of this table has a foreign key field. Okay, so it just have its primary key field, student and course ID. Now we are going to have a third table, in this case, student and course, and this is the intersection table or join table. Okay, so here, SID and CID. So these two columns are represented as foreign keys. So this is a foreign key to students, and this is a foreign key to courses. Okay, and then you can specify the primary key I like to use is a combination of the student key and course ID. Okay, so this is a way that you can specify the combination, composite of these two foreign key columns are used as a primary key. So in this case, this is the course table, and this is the student table. Again, you don't see any foreign key in each of these table because we have this intersection table, a join table, that has a foreign key to the student table and the course table. And as you can see, combination of each of this should be unique enough to be used as a primary key. All right, so let's do exercise 2. So exercise 2.1 is one-to-one relationship. Here we have a person table, and we have primary address table, and then we have inserted some data, okay, and to the primary key, okay, and you can see we are actually setting the foreign key column of the primary address table, okay. All right, and we just perform some inner join select and display number of primary addresses for each person and display number of persons for each primary address. Okay, so let's try that. Okay, so this is the person table, and this is the primary address table, and this is the join table. Okay. Oh, I'm sorry. This is not join table. This is the join table is. Oh, what am I talking about? Yeah, sorry about that. I'm just confused. Yeah, this is actually one-to-one, so we don't see join table. Yeah, I was just confused. All right, so in this case, we basically see a person table and primary address table, and here, basically select person's name and primary address of that person from these two tables, and we just basically do inner join. We want to see the people and their addresses. Okay, so that's basically what you're going to see the here. Okay, people and their addresses. Okay. And this one is display number of primary addresses in each person. So each person has a single number of address. Okay, so we basically use the count. Okay, aggregate function, and we basically use where and group by as we learned last week. Okay, all right. So that is one-to-one. One-to-many relationship. This is employees and department example we have seen. Okay, so here we are going to join. So basically display all the employee and their departments and the department's ID, employee ID's department ID foreign key value has to match with the department ID. Meaning we want to display all the employees who has a department ID. So this is pretty much the same example that we have seen. Okay, and this is the number of employees for each department. Okay, so basically we are displaying the count of employee IDs, the foreign keys. So if we run this one, okay, so these are the department, and this is employees, and these are foreign keys to department ID. Okay, and so this is 5 people and these departments, and engineering has 2 employees, sales has 2 employees, and marketing has 1 employee. Okay, so again, this is the same example that we have seen last week using group by. Okay. All right, many-to-many relationship is here we have student table and course table, and then this is a join table, intersection table, same example that we have seen, and then we have added uh, the uh, the uh, the data to the student and course table, and then intersection table. Okay, so display all courses that Jack is taking. Okay, so and this display all courses that Nicole is taking, and display all students who take MySQL and things like that. Okay, so let's see the example. All right, so this is a course Jack is taking, and the course Nicole is taking, and students who take MySQL. And so these are number of students per each course, and the number of courses each student is taking. Okay, so you can see this one has multiple 3 and multiple 2. Okay, all right, so that is the relationship. So let's move on to the next topic, referential integrity. So what is referential integrity? So foreign key constraint specifies that data in that foreign key must match the data in the primary key of the linked table. Okay. So for example, that D underscore ID foreign key field of employee table must contain a valid department number. Okay. So if you try to add new employee whose foreign key field column value is not one of the values in department table, you will experience an exception. Okay. And the department table cannot be dropped as long as there is an employee whose foreign key refers to it. Okay, so these are referential integrity. These referential integrity is maintained by the database server. Okay, it's not something that you have to deal with. You're going to experience an exception when you try to do something invalid against the referential integrity. But the database server is the one that actually makes sure the referential integrity on the tables, in fact, maintained. All right, so in this case, we have departments and the employees table, as we have seen here. Now, if you try to add an employee with department number with 6, okay, so there is no department number 6 here, and then you are going to experience an exception here. Error, cannot add or update a child row, foreign key constraint fails. Okay. All right, so let's try exercise 3. So we create these 2 tables, okay, that contains departments and employees. So we are going to create the table first. Okay. All right, so we can see select departments. So we have 4 records in the departments, and then employees. We see 5 employees. Okay, now if we try to add an employee with the DID, the um, uh, values of oh, so this is the case. So DID is the last column, right? So here we are not specifying, we are actually specifying null. Okay, so it will say no, you cannot actually make that foreign key column null. Okay, and values, and I'm gonna copy this one, and it says DID cannot be null. So this is the case. Next case is that I'm going to set that department ID foreign key value to 10, and 10 is not existent in the in this department primary key value as a primary key value. So obviously that will result in an error as well. So let's try. Oops. Okay, and values, and then try to 10, and again exception. Okay. All right. For updating records, so here I'm trying to update. Oops, I'm trying to update uh, oh, so basically I'm updating department ID value to 44. I'm basically changing department HR to 44 instead of 4. So basically I updated, meaning I changed the department ID to 44. Uh, That's okay because there is no employee record that actually use this HR primary key, so that's allowed. Okay, and if I see the departments, now we should actually see primary key value of HR department should be changed to 44. Okay, so it's changed to 44. Okay, now if I change again, I'm actually change it back to 4. So that's also allowed because again there is no one that is actually using 44 as foreign key value. Now if I try to change department ID, this one to 11, then you are going to experience an error because there is already an employee that is using in fact, there are 2 employees, Jack and Nicole, that are using department primary key value 1 as foreign key values. Okay, so this one is going to result in exception. Okay, because that will violate the referential integrity. Okay, so as you can see, we have these 2 errors. Okay, because we have 2 employees who are using that department ID 1 as a foreign key value. Okay, so deleting it. So here we are going to delete the HR, and we can delete it because there is no one that is using HR as a department. Okay, so if I select stuff from department, now we should see only 3 department records. Okay, employees are still the same. Now if I try to delete the department number 2, and again that will result in error because there is already a record that is actually employee who has that department. Okay, so the delete, so employees, and you can delete. Yeah, now we are going to delete employee number 2 that is actually using department ID 2 as a foreign key value. Okay, and then we should be able to delete the department whose department ID primary key field is 2. Okay, that's successful. And now if we see the departments, we are going to see only 2 departments. Okay, all right. Now you cannot drop departments table either because there is employees that are dependent upon the department. Okay, so drop table department. Okay, an error. So, but if I drop employees first, and then I should be able to drop departments. So drop table employees table, and then I should be able to drop department. Okay, so show tables, and we should not see any employees and departments tables anymore. Okay, so that is referential integrity. Let's move on to the table relationship, and the subtopic is automatic delete and update. So automatic delete and update is that, if you can specify on delete cascade or on update cascade to the foreign key references modifier, then it will enable automatic deletion or update of the records. Okay, so in this case, we now have employees table, which is again has a foreign key column, okay, pointing to department ID, but it says on delete cascade and on update cascade. Okay, what that means is that when the departments table gets changed, then the change will be cascaded. All right, so let's see example of this. So here we are deleting department number 2. Okay, and then because you specify cascade delete, any employees that belong to this department will be also deleted. Okay, so that is basically what we are seeing here. With department number 2 is deleted, and instead of getting an error, the database will actually delete the old employees that belong to that department. Okay, so let's try exercise 4. So here we are going to again create the departments and employees with the same values. But this time we are going to specify cascade on delete and update. Okay, so let's create those two tables. Okay, all right, so we should be able to see. Oops, yeah, I want to just say select from departments and select from employees. So same data. Okay, now we're going to try automatic update. So here basically what we are saying is that I want to change department ID of the first one, department ID 1 to department ID 11. Okay, and then employees records will be automatically updated as well. Okay, so here there is two employees, Jack and Nicole. Their DID value, foreign key value, will be updated automatically. Okay, so let's try update. Okay, now we are going to see employees. So you can see it's changed to 11. Okay, and of course, if you see departments, that value has to be changed to 11 as well. Okay, so you can see it has been changed to 11. Automatic deletion. So here we are deleting number 2. So we're going to delete ID equal to, we are going to delete the sales department record from departments table. Okay, so we are going to delete. And if you see employees, so let's see the employees, select. So there are two employees who have department ID 2 as is foreign key value. Okay, so if you delete the department, sales department, so let's delete the sales. Sorry about that. Just have to choose the right window. Okay, copy, select, and okay. Now if I see employees, copy, select. Now we should see those two employees whose department ID 2 are also deleted because we use a cascade delete. Okay. All right. Sorry. Okay, so moving forward. Now, the next topic is union. Union is used to combine the result from multiple select statement into a single result set. So, basically you perform this select and then this select, then you're gonna just union it. That's the result. Okay, so let's try the result union. So here we are basically create temporary table called the high salary employees and then low salary employees, and then we are going to perform union on that. Okay, so it's basically create temporary table is you're actually creating employees. This is a real table, and then you are creating a temporary table from it. Okay, only selecting these two columns, the e-name and salary. Okay, and then we are basically performing select statement on those temporary tables, high salary employees and low salary employees, and then we perform union. Okay, all right, so we're gonna try that. Right, and we are going to see. Wait a minute. So why it didn't? So let's actually take a look at the tables. And the one I want to see is Union SQL. Okay, so employees salary is okay, so that looks fine. So let me see. Oh, the reason is because because I'm actually using this employee table, which has just the 3 entries. Okay, so that's why. All right. Okay, so it was actually kind of different from here. That's the reason. Yeah, so here I was actually, this one is actually expecting that actually 5 employees, but since we are using this employees table, which has only 3 entries, that's the reason we got just 1 entry here. Okay, all right. All right, moving forward. Subquery. So what is a subquery? Subquery is a select statement within another statement, except that its result set always returns a single column containing one or more values. We'll see an example of that in the following slide. And the subquery can be used anywhere, an expression can be used. And subquery must always appear within parentheses. So let's see an example. The reason you want to use a subquery is that it allows you to build queries that are structured so that it's a bit easier to isolate the part of your statement. You want to actually separate kind of logics for the querying operations. And it lets you actually build SQL operations that could be complex joins, and if you do not use the subquery, it could actually end up being a very complex joins and unions. Okay, so and it basically lets you build more readable the SQL statement. So let's see an example. So in this case, what we want to do is that we want to get all the employees and their name and salary, whose salary is the greater than average. Okay, so here this is a subquery. So we are basically generating average salary value from employees. Okay, and then we are going to use that result on this where clause. So here we are going to actually see 3 people. Depending, we are going to actually see in this case probably just 1 or 2. Okay, because we have only one, three entries. And this is a case that, where department ID is sales. Okay. And then basically, so the result of this one will be used as a value for this. Okay. All right, exercise 6. So here are these examples that we have seen. So here we are creating, first of all, we are creating every salary from employees. Let's see how much that is, okay? And then we are going to select all the employees whose average salary is greater than average or less than average, okay? So again, in this case, since we have only 3 records, the values will be somewhat different from this, okay? But it should work as expected. Okay, so we have only one person who's greater than average, and we have 2 people less than average. Okay, and we have just three employees, and that makes sense. Okay, so if you see, okay, so that work as expected. And this is a case that we want to display all the employees whose department ID is the same, okay, as this. Okay, we're close. And basically, we want to actually get the department ID whose name is actually sales. Okay, so here. We have empty set here, okay, because we don't have Mary and Angie. Okay, the last one is view. So view is basically a virtual table, which is composed of the result set of a select query. So you're basically, it's like a cache in a sense. Okay, so that cache is a result of performing a select query. Uh, and view is exactly behaving like a table. Okay, so you can actually certainly perform query operation against the view, even though it's a virtual table. Okay. When the tables, which are the source data of the view changes, the data in the view changes also. Okay, so this is important. View is created from existing table, and if the table, the contents of the table changes, and the view, the virtual table also changes. So why view? So again, when complex query is called repeatedly, it will be beneficial to create a virtual table. Okay, and suppose if you have a table that has, let's say, 100 columns, and if you're dealing with only, let's say, 2 or 3 fields, and then you might in fact have create the virtual table that just contains those 2 columns and things like that. So here we created a virtual table called view table, high salary employees, and those people are who's making over $4,000. And then we have created low salary tables who's making less than 3,000. Okay, and then we can actually perform the query operation against that virtual table as if it is a real table. So here we are basically displaying, the contents. I mean all the records of that high salary employees. Okay. So let's see exercise 7. So here we are basically creating those high salary employees and low salary employees views. Okay. And then let's see, show tables. Oops. Show tables. And you see we have created these 2 views, right? Okay. And then we should be able to perform any query operation against these 2 views. Okay, select from. Okay, so there is only one. And you can also actually, so here we are going to add an employee to employees table, and then we are going to actually see whether those the views automatically be updated. Okay, so here we are going to add a new employee and values, and so here 65, so that should be high salary person. Same thing here. And then we have a low salary person. Oops. Okay, something is not right. Unknown column name in Okay, so looks like describe employees. Oh, so it's ename. Okay. All right, so let's try. Ename and values and one more. I will just finish that up. Oops. Okay, line 4. Oh, okay. All right, the comma at the end. Okay. Values. And then I'm gonna just add one person. And I'm gonna add the last person without comma at the end. Oh, it's because I'm actually working with the, I'm gonna just create a new tables here. So I'm gonna just use this one so that I'm actually working with correct table. Okay, so that's better. And then we're gonna just try. Okay, and show tables. Okay, and we should see this. Okay, and then I'm gonna try and values, and I'm gonna just add one and the last one too. Yeah, I should actually update the documentation. I don't know why it's actually that. Okay, name and values, and okay, so I'm gonna just use Tadu 7000 like this. That's department ID. All right. So I mean, I'm gonna just change this one later on. So basically, the idea of the view is that it works like the regular tables. Okay. Yeah. So I apologize. I should actually change some of this. Okay. So I'll correct that. All right. So I'm gonna actually finish that up.